In this particular video, guys, we are going to be solving for the variable r, and you can tell by looking at the equation that there's more than one variable for r. You've got the variable v for the velocity, g for gravity, r for the radius of the planet being orbited, and then h for the height of the object orbiting above the planet's surface. And I think now is a good time for us to remember that in real life, when you're dealing with finding unknown quantities, oftentimes there's more than one variable, as is the case right here. And so we're going to walk through this process algebraically, getting r by itself and what that looks like. And so the first thing that I'm going to do on this particular equation is I'm going to divide both sides by the square root of 2gr. And the reason that I'm doing that is that allows me to cancel out the square root of 2gr on the right side of the equation, and then it's going to make it easier for me to deal with when it's on the left side of the equation. So I cancel it out here, and I'm left with this equation: v divided by the square root of 2gr equals the square root of h divided by r plus h. Remember that our job is to get the r by itself, and that's what I'm taking you through this step-by-step process. And so really it's just solving equations using inverse operations a whole bunch of times in a bunch of different ways. And so now when you have this equation, v divided by the square root of 2gr equals the square root of h divided by r plus h, what we're going to do here is we're going to square both sides. And the reason that we're squaring both sides is that will cancel out the square root, and we won't have to deal with the square roots anymore. We'll still have fractions, but we won't have square roots to deal with anymore. So now I have the equation v squared over 2gr equals h divided by r plus h. And so as I continue moving forward here from this particular equation, what I'm going to do now is I'm going to remember the fact that whenever I have two fractions that are equal to each other, their cross products are equal. And so I can say that this v squared times the quantity r plus h is equal to 2gr times the h. And so my new equation is v squared times r plus h equals 2gr times h. Now the reason I did that is now I don't have to deal with any more fractions for right now. Okay, and so then it gets a little bit easier to solve for r after we do a couple more things. And so what I'm going to do is I'm going to multiply the v squared times the r plus h, and that gives me v squared r plus v squared h equals 2g rh. And so as I continue in this particular problem, I have to subtract 2grh from both sides, and the reason I'm doing that is I need to get all the r's together. So I've got v squared r plus v squared h minus 2grh equals 0. So now I've got everything on one side of the equation. I've got my r's a little bit closer to each other, and I can use this little property called the commutative property to switch those guys around. And so now I've got v squared r minus 2grh plus v squared h equals 0. And the reason that was important to me is now I can factor out an r out of those first two terms. So I've got r times v squared minus 2gh plus v squared h equals 0. So I'm just taking this step by step. So now I'm almost done. So what I'm going to do from this equation is I'm going to subtract v squared h from both sides, and that gives me the equation r times v squared minus 2gh equals negative v squared h. And then you're just going to divide both sides by the v squared minus 2gh. So I have solved this equation now for r. And sometimes you have to do that. And while it looks like, oh my gosh, that was a whole lot of work, remember it's just step-by-step inverse operations that you're using to solve that problem.